Students, even the average person, may tend to believe that when two objects of different mass or velocity collide, one greater in either or both of these variables will exert a greater amount of force on the other than vice versa. But in scrutiny, one will find that this is a fallacy. The interplay of any physically heterogeneous objects requires that the forces they mutually exert are equal, as mandated by Isaac Newton's third law of motion. That for every action there is an equal but opposite reaction. To demonstrate, two wheeled objects face each other from a distance. The wheels and brick-by-brick construction of these objects were the same to ensure the same friction coefficients and mass, respectively. Compared to object A at left, object B at right is twice as far from the intended collision point between them, but a greater force will be applied upon it such that both objects will collide at about this point between them. Afterwards, neither object stopped where it started, but the A to B ratio of their initial distances from the collision point and the A to B ratio of their final displacements from that collision point in correspondence are approximately equal, with a minor numerical disparity likely resulting from the fact that the bumpers were not exactly parallel upon collision. But this equality of displacements in rate proportionally speaking is only possible because their horizontal net forces upon collision were equal, as neither influenced the speed or acceleration/deceleration rate of the other, only the direction. Ergo, the difference between the forces applied on two objects does not influence the equality of their net forces mutually exerted upon each other upon collision. Next, the two objects begin equidistantly from their collision point, but object B has a greater mass and thus, with more gravity and ergo frictional forces, will require a greater applied force than object A at left, for these objects to have the same displacement at the time of their collision. Just like their initial displacements, the final displacements of objects A and B from their collision point are approximately equal. Object B had more applied force, but as mentioned earlier, it also had greater frictional force than object A. And this balance of forces allowed for an equality of horizontal mutual net forces that allowed for this equality of final displacements to be possible. Although the greater friction in object B likely caused a greater deceleration rate after the collision such that its final displacement was slightly smaller than that of object A. But nonetheless, an equality of mutual net forces upon collision is evinced. In conclusion, Newton's third law is cognitively and intellectually understood by the masses, but not perforce applied in the same manners. So whenever you move a chair, table, desk, or even couch, remember that it is not simply you working against its forces. Those objects, though inanimate, work with the same magnitude of net force against you. Thanks for watching.